All right. So while you guys are thinking about it, I'm going to go ahead and get started. So it just keeps doing that. So you're going to build your data set as a list. So in Desmos, using Desmos, you're typing in exactly what I have there. You can name your data set whatever you want as long as you use a capital letter. Let's pay attention. You can call it whatever you want as long as you use a capital letter. So I'm going to call it capital S. And then I put in equals, just like it's written right here, equals. And then I'm going to use this bracket. I'm using the bracket, the symbol right next to the number P, right next to not number P, the letter P. Do you guys see that bracket? And I'm going to input that data set. 1, 2, 3, 4, 5, 6, 7, 6, 8, 6, 9, 6, 7, 8, 5. So you should have 15 elements. Let's make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes. So do you see how it tells you have 15 elements in your list? You hope that that's right. Okay. So count and make sure that that's how many you have. Well, if you want to find the mean, which is the average, all you do is you go down to the next entry, right, in your Desmos, and you type in the word mean. And then now you're going to use a parenthesis and whatever you named your set. You named it capital S, capital P, whatever. So here is our mean. This is our mean. So what is the mean or the average for this data set? 5.53, and the 3 repeats itself. But what if I want to know the median? Well, same idea. I type in the word median. It's written right there for you. Parenthesis, capital S. So what is the median number in our data set? 6. Desmos cannot calculate the mode or the range for you. Cannot. You have to do that yourself. Which number appears the most in our data set? Anyone? 6. What is the range? Large minus the small. The largest number is 9. Minus the smallest number, 1. 9 minus 1 is 8. Okay. All right. So I'm going to show you how Desmos can make a histogram for you. So all you do is type in histogram, histogram, parenthesis, whatever you named your set. And look at that. There's your beautiful little histogram right over here. You see that? Okay. Do you see the directions right here? Histogram, parenthesis, whatever you named your set. Okay. What if I want to make a dot plot? Well, I'm going to go down here. I'm going to get rid of my histogram, and I'm just going to type in dot plot, DOTPLOT, whatever the name of my set is, parenthesis, capital, whatever. Look at my dot plot. Okay. What if I want to make a box plot? Well, I'm going to get rid of my dot plot, and I'm going to put up, actually, I'm going to leave my dot plot there. I'm just going to white it. I'm going to put my box plot up there. So box plot, shift, my set is capital S. So there's my box plot. The cool thing about your box plot is when you put your box plot over the top of your dot plot, look what happens. Do you guys see how they overlay on top of each other? Pretty cool. All right. 5-number summary. 5-number summary. So now we're going to go to our calculator. I want to show you that this is the easiest way. Your calculator is the easiest way to do this. So we're going to use our calculator directions. Calculator directions. Okay. So calculator directions say to do what? If I want to put in data into my calculator, what do I do first? Stat, edit, input a data list. So stat button, everybody knows where your stat button is. Edit, you have to input your data list. Okay. Does everyone remember how to clear out your list? Go up into L1, arrow up into it, and clear it. So the numbers I'm putting in my data set: 1, enter; 2, enter; 3, enter; 4, enter; 5, enter; 6, enter; 7, enter; 6, enter; 8, enter; 6, enter; 9, enter; 6, enter; 7, enter; 8, enter; 5. Once you do that, make sure it says that you have 15 elements in your set. So if you like arrow up to the 5, it should say L1 has 15. It's the last thing you put in there. L1 has 15. Stat, edit, enter. So I want you to go over here to L1, and I want you to clear it out. And I want you to put your data right there. L1.
Because you're down ready to enter another one.
Are we good? Does everybody have it put in there? Does everyone see that L, like that 5 has, so to clear this out, I want you to just arrow up to L1 and just clear, and then go down here, this is clear. And put all those numbers. All right, so what does the next direction say? Once you build your list, what does it say to do? Calc what? Yeah, so you're going to hit your stat button again. You're going to hit your stat button again. So everybody hit their stat button again and use your right arrow to get to the calculator. And you're choosing one variable statistics. You see that? One variable statistics, which is what it should be highlighted on. Right? Click that. That's great. Stat button, right arrow, calculator, and choose the first one, one variable statistics. And then you have to arrow down to where it says calculate, right? Okay, so you should see some really cool things in there. Like, the first thing that you should see is an X with a bar over the top of it. What does that stand for? The mean. What is the mean of our data set? Isn't that exactly what we wrote up top for our mean? It is. Okay. What is the N stand for? It says N equals 15. What does that tell me? The number of elements. Arrow down. Do you guys see how there's an arrow next to your N? Arrow down. What's that tell you? The minimum. What is the minimum value of my data set? Oh my goodness. 1. Arrow down. What does that give you? Arrow down one more. It gives you what value? No. Right after your minimum, it should give you a Q1, right? What does your Q1 stand for? Your first quartile. Arrow down again. It gives you a median. Remember that your median is also called the second quartile, but we always call it a median. 6. We already calculated that in Desmos. What does the next one give you? Q3, third quartile, 7. The last one gives you your maximum of 9. How are we going to calculate the inner quartile range? We talked about Q3 minus Q1. Let's see. That's going to be 7 minus 4, which equals 3. So our inner quartile range is 3. Your inner quartile range is 3. Okay. When you look at your directions down here, do you see this SX? It says standard deviation. I tried to tell you what everything looks like in your calculator. Do you see that? SX. Do you see arrow back up to where right below your, like up by your mean? Where do you guys see for SX? What numbers are there? 2.26. This is your standard deviation. Remember that describes the variation. It's a variation. It tells us about the variance in the data set. N is the number of elements. Do you see how I have this written down here? This is all the information that you're going to need from your calculator. Okay. Questions about that? Okay. I want to go back up to our box plot just for a second. So someone tell me how to label the parts of my box plot. We did this the other day on our graphical representations. What's this first thing telling me right here? The minimum. This is the minimum value. So that means that the other whisker N tells me the maximum value. This was part of our journal the other day. Okay. Where is Q1 located? At the first box, right? This is Q1. And that means this is Q3. And the line inside of the box is the Q2 or the median. We pretty much always use the median. And then we wrote something very special about the box. What does the box hold? Look at your journal entry. The box holds something very special. You always get a question about it and we can never answer it. Justice, open your eyes. You don't learn with your eyes closed. What does the box hold? We wrote something inside of it. How much? Inside the box is 50% of the data. 50% lives, 50% of our data is inside the box. That means this little whisker outside has 25% of our data, and this little whisker on the other side has 25%. Alrighty. I'm just going to keep on going with this into our notes. We're just doing 3 examples, and then we'll do our journal. Okay. So go ahead and turn your page. And we're going to talk about graphical representation. So now remember, we did the journal entry for this the other day. So a farmer is studying the weight of baby chickens after 1 week of growth. They find the weight in ounces of 20 chicks. The weights are shown below. We have to construct a dot plot. So when we did our journal, we said that when you make a dot plot, you can either use zeros or X's, right? So what are we going to do for each? Like when I see this, I have a baby chicken that weighs 2 ounces. What am I going to do? What am I going to do for this value? Yeah, I'm going to go to where 2 is on the weight of 1 week old chicks, and I'm going to put a circle. And then I'm going to do the next number. I have 1 chick that weighs 1 ounce. It's the runt. I'm going to put a circle on that one. And then I'm going to go to the next data point, a 3. I'm going to put a circle there. And then I have a data point of 4 ounces. I'm going to put a filled in circle right there. And then I have another 2. Filled in circle. I have another 2. Filled in circle. I have a 3. Then a 1. And a 5. Are you guys with me? A 3. A 4. Another 4. Do you see how once I make the plot for it, I cross it out so I don't reuse it? A 5. A 6. A 3. An 8. A 5. A 4. A 6. And a 3. So your dot plot should look something like that. Which number do you think appears the most? How could you do that so quickly? Because your plot was the tallest, right? The 3s were the tallest. So you can really see some quick information from a dot plot, right? Okay. Next, we're going to look at this histogram. This histogram shows the ages of the workers at Charlie's Food Factory. It says from exercise 1, but I cut that one out, so it's really not from exercise 1. So we're going to look at this. Remember, we said that a histogram has these bars that are right next to each other, and the x-axis represents a range, right? So each one of these bars or bins, remember we called them bins, represents an age range. So how many workers fall in the age range between 19 and 21, Gianna? 11. How did you do that? Yeah, you see where it matches on the y-axis. Remember that your y-axis is your frequency. Tells you how many. So 11 workers. Okay. What is that's workers, sorry. What is the disadvantage of using a histogram compared to a dot plot? How many of the workers were 22? Were they? Oh, you don't know an exact value for a data set. So I put you don't have data for a specific variable. You only have a range. And Gianna, you couldn't have answered that better if I had like planned ahead of time. That was perfect how you did that. We want to say that it's 2, but we don't know, right? We don't know how many of those workers. There could have been none of them that were 22. They could have all been 23. Does the histogram have any advantages over a dot plot? Well, we talked about when to use a histogram versus a dot plot. If you had 2,000 data points, would you want to make a dot plot out of that? No. So I would use a histogram when you have very large data sets. That's one thing I would do. So I'm going to say histogram when you have large data sets. Okay. It's also easier to see the amount of data points in the range. And by that, I mean, you just can look and we kind of drag the arrow over to the 11. We don't have to count dots. So I'm going to put that we're not counting dots. So if I had 100 people in a data range, like in my range, it'd be really easy because I would just drag my bar over to the y-axis to see the frequency versus trying to count 100 little dots. So it's just easier to see the total amount in the range. You don't have to count a bunch of dots. Are we good with that? Okay, flip it over. We have one more example. So when we did our journal last, I think it was on Monday, we talked about data sets, right? And we said when we make a histogram, we want to make sure that we keep the bars right next to each other, right? There's no space in between the bars. So the first thing that we're going to do is complete this frequency table. So this shows the high school varsity basketball team's scores, like total points scored for their last 20 games or for the 20 games that they played. So these are actually scores. So that's what my x-axis needs to be labeled as. And give yourself some space to label your bins, but this is scores, right? Or points, I guess I should say. Maybe points, because it's a basketball thing. And then what is this on the y-axis? What do we say the y-axis represents? The frequency, right? Number of times. So I'm just going to write frequency here. All right, so let's fill out our little tally chart. So let's see. One game was a 76. So that's going to go right here. Then we had a score of 55. in the 50 to 59 range. We had another score of 76. That's going to go in the 70 to 79 range. We had a score of 64. That goes in the 60 to 69 range. Where's this score going to go? In the 40 to 49. Yeah. Where's this score going to go? 90 to 99. Yep. 65 goes in the 60 to 69 range. 46, 40 to 49. 45, 40 to 49. 53, 50 to 59. 56, 50 to 59. 53, 50 to 59. 57. When you get to 4, the fifth one goes across like this. You guys remember doing that, right? With tally marks? Okay. 67 goes in the 60 to 69 range. 58, 64, 67, another across, right? Because that's 5. 52, 58, and 62. Again, once I mark it or tally it or whatever, I cross it off. So how many games did they only have a score of 40 to 49? 3. How many of their games did they score between 50 and 59 points? 8. How many of their games did they score between and then 70 and 79? 80 to 89 and 90 to 99. Okay. So we want to label our bins down here. We want to label our bins, but the first thing that we need to do is put a break in our axis, right? So we're going to put a little break. So I'm going to start at, I'm going to make this nice and big. I'm going to start with my first bin at 40 to 49. So I skipped the first 2 grids and I just drew a little break in my axis. Remember, that's like a squiggle. Gave myself a break. Then my next bin is 50 to 59. It's 2 bins wide. And then my next bin or range 60 to 69, 70 to 79. Should I skip the 80 to 89 since I didn't have anyone score in that? No, I should not. Good job. We want to make sure that we include all of the numbers. We can't skip ranges, right? The increments of your bins have to be the same. That was a trick. I was trying to trick you. And then 90 to 99. Okay. So do we all have something like that? All righty. So my first bin, 40 to 49, we need to label our frequency axis on the right. How do we want to, or on the left, the Y's. How do we want to count that? Each grid should just be worth what? Can it just be worth 1? Do we have enough grids? So can I just label like every other one? So basically count by 2s. So 1, I'm going to label 2. 3, I'm going to label this one as 4. 5, label this one as 6. Go up a little bit. 7, label this one as 8. 9, label this one as 10. 11, label this one as 12. Is that okay? Everybody got their little frequency labels? Okay. So 3 fell in the 40 to 49 bin. So I go up to where my y-axis is 3, and I just make a rectangle, right? And I'm going to just shade it in lightly. I'm not going to go crazy. I'm just going to kind of do that. That's my first one. And then in the 50 to 59 range, how many games did they score that point? 8. So I'm going to go up to my y-axis where 8 is, and I'm going to put a line across the top, and then I'm going to turn that into a rectangle. And I'm going to shade that in. If you guys want to shade it in different colors for each bar, you can. It's totally up to you how colorful you want to make it. I don't care. I just want you to make sure that there's no gaps in between your bars, right? They're right touching each other. What about in the next one? 6. So I'm going to make another bar. Go across to the 6. Color that in. I don't know why this is refusing to keep the color in this bar. Okay. What about 70 to 79? 2. So let's see. 1, 2. 70 to 79. What about 80 to 89? 0. So don't put anything there. What about 90 to 99? 1. So I'm going to go up to the first grid. There we go. So this is what your histogram should look like. Your beautifully constructed histogram. You've labeled your axes, you've labeled your bins, you put a break in your axes since you weren't starting at 0. Fabulous. What do you think? Good? Okay.